here's the proof for the product rule of derivatives. So hopefully you know that from today in notes. But as we kind of go through this proof, we're going to take f of x times g of x, and we're going to call that capital F of x. And then here, remember, like we learned last chapter, the definition of a limit is, if we're doing this capital F of x, it'd be capital F of x plus h minus f of x over h. So that was kind of the definition of a derivative that we did last chapter. Now what I'm going to do is I'm going to plug in the red f of x function and the green g of x function. And then what's kind of interesting, so if you see how we went from this step to this step, what I have here added in is the orange. And do you notice, like, kind of look over that orange terms, the terms there, they would actually add up to 0. So you're allowed to do that. You can add 0 to anything you like. And then what I did, I took this from the book. So what the book did, okay, is this is just subtraction. I put that one over here, and then this I added with this term. And we're just adding the limits of that. So it's kind of like we just thought of this as two separate fractions. And then, if you can see in this next step, we factored out an f of x plus h from this term. And here, factored out of g of x, because that's what they have in common. And then what you'll notice you have left is kind of split these fractions apart a little bit. As h goes to 0 of f of x plus h, don't you see that's just going to turn into f of x. This is the definition of the derivative of g. Here, as h goes to 0, g of x is just going to stay g of x. And this is the definition of the derivative of f of x. So there is a fun little proof of the product rule for derivatives. Same idea for the quotient rule, and this is in your book. Again, you're welcome to write this down, but I just think it's kind of an interesting proof, and I want you guys just familiar with proofs. So again, we use this proof by using the definition of a limit, okay, and then here I got common denominators. That's why I chose to multiply by those. So now we can write this as one big fraction. What happened here? So we just took this big fraction and kind of split it apart. And what you're going to notice as h approaches 0, do you agree the denominator is just going to become g of x times g of x, or g of x squared? So I kind of just took care of that kind of all at one time. And then here's the rest of our fraction. And notice what has been added in orange. I have a minus f of x g of x and a plus f of x gx. So those, again, that just adds up to 0. And then I brought this term in with this part of the fraction, and then this term here. Okay? And was able to, so like here, of these two terms we factored out an f of x. Of these two terms we factored out a g of x. And then kind of the same idea happens as what happened in the other proof. You can get this to look like the definition of the derivative of f, the definition of the derivative of g, and kind of just put everything together until you get what the quotient rule actually is. So hopefully you found that interesting. It's up to you if you want to write it down or not, but I just wanted you to be familiar with the proof.